Hello and welcome to this lab lecture on train validation test split. In the 101 lecture, we have learned how important it is to perform this training validation test split. And now we put this into action. In this lecture, you will learn how to write your own function for splitting the data into different partitions for training, validation, and testing. And this is something that we will use in the rest of this course a lot. So we will always use this train validation test split and make use of our own function a lot. So that's it. Let's get started. After you have downloaded and extracted the file from the homepage, you can see these three files: the projects file, a template file, and the final file. And please click on this project file so that RStudio is starting. Now please open the template file, because this is the one we will use for now. In the beginning we will load some packages. We will use dplyr, caret, and keras in this tutorial. And at first we will create some artificial data frame. So this is just a tibble, which is very similar to a data frame, with one column X, and this is having 1000 rows with the values from 1 to 1000. Very simple, but that's everything we need for playing with. And later on we will also need a variable called nops for the number of observations, which is calculated with the function nrow, where the data frame is passed. After we have created our own data frame, we now want to split it into training, validation, and testing. But at first, we need to define the different ratios. So how much data should be reserved for training, how much for validation, and how much for testing. Let's call the first variable train ratio, and we specify it with 0.6. The next one is validation ratio, which we set to 0.2, and test ratio is going to be 1 minus train ratio minus validation ratio. So we now have 60% of the data for training, 20 for testing, and 20 for validation. The first operation we are doing is not necessary, but I want to make sure that you get the exact same results that I have. So I set the seed to be 123, and now I create an object called sample size for the training data, and this is the floor value of train ratio times number of observations. And since we have 1000 observations, that would result in 600 observations for the training data frame. And we do the same for the sample size validation. And again, we are using the floor function. This time we pass the validation ratio times the number of observations. And the last time, sample size test. Again, we use our floor function, pass the test ratio times the number of observations, and run the complete chunk. Now we want to create some indices for the training, validation, and testing data that are pointing to the specific rows in the data frame. So for this, we define a new variable called indices train. And from the base package, we will use the sample function, where we specify at first the overall vector, which is going from 1 to 1000, and we take in this case 600 samples, which is specified in the parameter sample size train. So you now can see we get a lot of samples in here. And for convenience, we can also sort this. Now we have it in a sorted way. The next point is to define the indices that are not defined by now. So we want to get all the indices that are not defined for the training right now. Indices not train, and for this we can use a function from the base package, setDiff, where we specify the complete vector, which is from 1 to 1000, which is number of observations, and indices train. And you have seen indices train, we're starting with 2, 3, 4, 5, and so on, and now we have all the residual values. And the total count of indices train is 400, whereas the indices for training reserved are 600. So everything seems to work out so far. And why did we do this? We did this because we now want to get the indices for the validation. And we do this similar. Now we can take again the sample function and pass here at first the indices that are not the training indices, so the residual ones that are not specified so far. And out of this we take 200 samples, which is specified in the variable sample size valid. And what's left is to define the indices for the testing data frame. This is simply done with setDiff. I also make sure that we use the right package base, setDiff, and we specify here indices not train, and all the indices that are not in the validation are the ones that are residual for the testing. And we are close to the end. So what's now missing is that we get our data frame df and specify the locations, which are indices train, as the rows. The columns are not defined, and this result would be then assigned to the training data frame. And similar, we do this for the validation data frame. And the last time for the testing data frame. Let's run everything. And you can see now we have our overall data frame unsplitted with 1000 observation and 200 for the testing and validation. The training has 600 observations. That's good, but a bit manual. Now we will create a function out of this. And the function is going to be called train val test split. And it's going to be a function which is getting a data frame df as the first parameter and some parameters for the train ratio. We can also define some default values, 0.6. Val ratio is by default 0.2 and test ratio is by default 0.2. And now we take the first parameter. It's a bit copy pasting. So we had some interactive approach to come to this result. Now we take all the different pieces that we build up in the way of getting there and put this into the function. So the first one is the number of observations which we need. Then we will need the sample size calculation, the indices calculation, and then the assignment to the 3 different objects. And let's just make the indentation correct. It's just some visual stuff, it's not relevant for the function. This is very close to the end. What we now will do is we will return a list which is providing 3 different objects: train, validation and test. And we run this complete chunk. I can also run it with the play button. So the function is now available in our environment. And there is a specific reason why I loaded the Keras package. We will use Keras a lot later on in this course when we will work on deep learning, but it also has a very nice function which is a multi-assignment operator. And this is quite fancy. I can show you right now how to use it. At the left side you specify a vector with 3 different names, and on the right side we call our function and pass our data frame. Oh. That was of course my mistake, because that's the normal assignment operator. That's not what we're looking for. This one is the operator that we need. So if we run this, you can see these 3 objects were created. They were there before because we ran it interactively, but it was created again. And that's really helpful. So with 1 line of code, you can create the complete training, validation and test split. And I didn't find any package that is providing this functionality. So we will use our own function in the rest of this course. At this point, we would have covered a lot of the data preparation and could go directly forward to the modeling part, which is not in the scope of this lecture. So thank you very much and see you in the next lecture.